finding the empirical formula of a compound from the percent composition. A certain compound of carbon and hydrogen is found to be 81.7% carbon and 18.3% hydrogen by mass. Determine the empirical formula of the compound. What is the empirical formula? The empirical formula is the formula with the lowest whole number subscripts with the same ratio as the molecular formula. What do the subscripts mean? First of all, they represent the number of atoms in the molecule. But they also represent the number of moles of atoms in a mole of molecules. So if we find the ratio of the numbers of moles of the elements, we can find the empirical formula. How do we find the number of moles? Remember that the molar mass of an element is the mass in grams divided by the number of moles. So we can find the number of moles if we divide the mass of the element by its molar mass. How do we find the mass of the element if we are given the percent composition? The easiest answer is to take 100 grams of the compound. Then the percentages become the masses. So, the first thing we do is to convert the percentage to a mass so we can find the number of moles. In this case, if we take 100 grams of the substance, then 81.7% is 81.7 grams of carbon, and 18.3% is 18.3 grams of hydrogen. Here is the beginning of a list of things we need to do to find the empirical formula. We will add to this list as we go through the problem. So the first thing we do is convert the percentage to grams. Next, we find the moles of each element. To do this, we divide each of the percentages by the molar mass of the element that we find in the periodic table. So, we divide 81.7 grams of carbon by 12.011 grams per mole. And we divide 18.3 grams of hydrogen by 1.008 grams per mole. This gives us 6.8020981 moles of carbon and 18.154762 moles of hydrogen. So back to our list. The second thing we do is find the moles of each element. Now that we have the number of moles, we need to make a ratio, because the empirical formula is the lowest whole number ratio. How do we find the ratio? We divide each of the mole answers by the smallest mole answer. This will make the smallest number a 1 and all the others larger than that. In this case, the smaller number is the moles of carbon, 6.8020981. So, we divide the moles of carbon by that, and we divide the moles of hydrogen by that same number. This gives us exactly 1 mole of carbon and 2.6689944 moles of hydrogen. So the third thing we do is divide each of the numbers of moles by the smallest number of moles. At this point, we have 1 mole of carbon for each 2.66 moles of hydrogen. Can we just round off the 2.66 to a 3? The answer is no, because the ratios must be very close to whole numbers, because of the law of definite composition, which says elements combine in small whole number ratios of their atoms to make compounds. How close? In order to round off a ratio to a whole number, use the following rule. If the first decimal place is a 0 or a 9, round it off to the nearest whole number. If not, then don't round off, but instead find a multiplier. This is because the numbers of atoms in a molecule are in small whole number ratios, which usually means numbers less than 10. This rule works for any molecule with subscripts less than 10. In the examples below, the numbers on the left cannot be rounded off to whole numbers because they do not have a 0 or a 9 in the first decimal place. But the numbers on the right can be rounded off because they do have a 0 or a 9 in the first decimal place. Now back to the problem. In this case, the moles of hydrogen, 2.66, are not close enough to a whole number to round off. So what do we do? If the ratios are not close to whole numbers, then we must multiply by a common whole number to make them all close enough to whole numbers to round off. So the question is, what whole number do we use? The brute force method is to just try 2 to see if that works. Then if that doesn't work, try 3. If that doesn't work, try 4, and so on until you find a multiplier that will work for all of the molecules. Another way to do it is to look at the first few decimal places and remember the decimal representations for 1/2, 1/3, 1/4, and so on. Then you can get a clue as to what the number will be. In this case, a 3 works to produce exactly 3 moles of carbon and 8.00 moles of hydrogen, which is now close enough to a whole number to round off to 8. So the fourth thing we do is, if necessary, multiply all the moles by the same whole number to make all of the ratios whole numbers. The final thing we need to do is to actually write the formula by using the rounded off numbers for the subscripts. So the empirical formula is C3H8. Here are the 5 things we do to find the empirical formula from the percent composition. You may pause the video to write them down if you wish.